Hello bachcho, welcome to MemoNeet. I am Sakti Swarup, teacher of MemoNeet. So in the previous lecture I have completed the first revision class for the current electricity, in which I have done some few questions. Okay. So in this class we will continue that. So before I will solve the question for you, I just want to tell you that what you are doing during the lectures, during this type of revision videos. So please, when I am giving you questions, pause the video and first you attempt the question and let you complete the question, find the answer, then see the video. That will be more beneficial for you, because at the same time you are watching the lecture and also solving the questions and also getting the proper explanation for the lecture. Okay. So one thing I just want to remind you also, in the Telegram channel I have conducted a grand quiz. Okay, those who have not appeared, just go to the Telegram channel. It is that message was pinned. Okay, click on the option and you will get the questions, attempt the question, and if you have any doubt in the question, the video solution is also there. You can refer to that. Okay, and this will have some 15 to 20 questions which will be very much standard question, and this will be more beneficial for you because you have a certain ample amount of question which I am giving you directly. What the expected type of question I am telling you, that these are the expected type of question that will come in the next NEET exam also. Okay, we have having the proper analysis. After that I am giving the questions, because one thing I have one pattern I have observed from the NEET, because the Kirchhoff's law, let's say Kirchhoff's law every year 1 to 2 questions normally comes in the NEET exam. Okay, so that's why I have given more question on Kirchhoff's law or the circuit. Okay, and some question are also from the drift velocity, and every topic I have covered in that grand quiz. Okay, you can go and refer to that. So let's start today's lecture. We will be starting from some question number 13, 14 or 15. Okay, so let's see it. Two electric bulbs, 40 watt and 200 volt and 100 watt and 200 volt are connected in series. Okay, then the maximum voltage that can be applied across the combination without fusing either bulb. Okay, so question is asking that two bulbs is there, that is of 40 watt and 100 watt, and they are having the potential 200 volt. Okay, and they are connected in series. Then what will be the maximum voltage for the combination? Okay, so if I will draw here the figure, we have here one bulb, okay, and here another bulb. These are connected in series and it is applied to a potential, let's say it is V, and this is 200 volt and power is 40 watt, and here it is 200 volt and the power is 100 watt. And what should be our maximum voltage so that the bulb will not fuse, any of the bulb will not fuse? So let's find out the current here. Okay, not the current, we will find out the resistance here. Resistance R will be equals to V square upon P, we know that. Okay, power is equals to V square upon R, so the resistance will be V square upon P. So V square, that is 200 into 200 upon 40. So this is 5 into 200, that is equals to 1000 ohm. It is R1, and the R2 is equals to 200 into 200, and the second one power is 100 watt. So this will be equals to 400 ohm. Okay, so this is 1000 ohm and 400 ohm. So the R net resistance kitna hua? That is 1400 ohm. Okay, 100 plus 400 as they are in series. So I can write, if I will write the current, the potential drop through one bulb, what I will write? Let's say this is first bulb and this is the second bulb. So potential drop, that is V1, is equals to V1 is equals to I into R. Okay. So how much maximum potential drop can be occur in this bulb? In this bulb, how much maximum potential can occur? That is 200 volt. Okay. We have here it can support 200 up to 200 volts. So we are taking 200 is equals to I into, as they are connected in series, the current will be same. So I into R1. Okay. So I is equals to V upon R1 plus R2 into R1. Okay. So if I will write here, 200 is equals to V upon R1 plus R2 is 1400 into R1. R1 is 1000. Okay. So this will be we have the potential as 0 0 cancelled out, and here 1 0 1 0 cancelled out. So 14 into 2, that is 280 volt. So our answer is option 1, that is 280 volt. Why I have not taken the second bulb? Okay, second bulb में क्यों नहीं लिया हूँ? Because the resistance is, as the resistance is 400 ohm. Let's find out. Okay, before I will tell, I will find this out and so why I am not taking this. Let's see here what will the maximum current this bulb can bear. Okay, this bulb can bear maximum current. P is equals to V into I. Okay, so I is equals to V upon P. It means 200 upon 40, that is equals to 5 ampere. Okay, sorry, I is equals to P upon V. Okay, this will be P upon V. This is P upon V. So this will be equals to 40 upon 200. It means 1 upon 5 ampere. It can bear the maximum current. So I1, let's say it is I1. So what maximum current bulb 2 can bear? Bulb 2 can bear, that is I2 is equals to P upon V2. Okay, P2 upon V2. So P2 is 100 upon 200, that is equals to half ampere. Okay, so if the current will pass more than 1 upon 5 ampere, what will happen? Bulb 1 will fuse. Okay, bulb 1 will fuse. For that condition, we are taking the potential drop at which will be suitable for the first bulb, not for the second bulb. अगर second bulb के लिए लेंगे तो हमारा current तो ज़्यादा आ जाएगा first bulb से, तो हमारा first bulb क्या होगा? Fuse हो जाएगा, तो कोई मतलब का नहीं रहेगा ना. तो in this question it is clearly given that without fusing either of the bulb. Okay, so which current should we take? That is this one. Okay, this I1 we will take. Okay, so that's why we are solving for the first bulb, not for the second bulb. According to the first bulb we are solving. Okay, let's see this question now. In the following figure, current through the 3 ohm resistor, that is 0.8 ampere, and the potential drop through the 4 ohm resistor is. Okay, through the 3 ohm it has given the current is this current, let's say it is I1, it is equals to 0.8 ampere. Okay, so let's find the current here. First division of current we will find. This is I, this is I1, this is I2, and then here I is flowing. Okay, so if I will see here the value of I1, it is given that it is equals to 0.8 ampere. So if it is 0.8 ampere, so what should be the potential drop in between 3 ohm? Okay, in the 3 ohm resistor. So this will be equals to I1 is equals to 0.8. So the potential drop V is equals to I into R. V is equals to I into R. So it is equals to 0.8 into 3 is equals to 2.4 volt. So 2.4 volt drop in between drop while passing through the 3 ohm resistor. So 3 ohm resistor से अगर 2.4 volt drop हुआ है, so how much voltage should be dropped from the 6 ohm resistor? It is also 2.4. Why? Because they are in parallel. In the parallel, the potential drop remains same. Okay, so we know that the VI2 will be V upon R. Okay, so this will be 2.4 volt drop upon the resistance, that is 6, that is equals to 0.4 ampere. Okay, so here 0.4 ampere, I2 value is 0.4 ampere. So the I will be, what is the current will be? Current is equals to I1 plus I2, which will be equals to 0.8 plus 0.4, that is equals to 1.2 ampere. Okay, so 1.2 ampere current is flowing through the circuit, and when it will flow through the 4 ohm resistor, so what will be the voltage drop? Okay, so this is equals to V is equals to I into R. Okay, so I is 1.2 into 4, how much resistance it is? 4 ohm. So it is equals to 4.8 volt drop from the drop through the 4 ohm resistor. So what will be our answer? That is option 3 is our correct answer. Then our next question, that is a galvanometer having a coil resistance of 100 ohm gives a full scale deflection when current of 1 milliampere is passed through it. Okay, what is the value of the resistance which can convert this galvanometer into voltmeter giving full scale deflection for a potential difference of 10 volt? Okay, the resistance required in series to convert it into voltmeter of range 10. Okay, so what it is telling, before I will go to the question, let's see the key concept. Key concept for this will be, when we are changing a galvanometer to voltmeter, what we are doing, this is the galvanometer and we are applying a shunt which is series to with the galvanometer. So this is shunt which will be in series to the galvanometer. So this will be our it will convert it into a voltmeter. Okay, so here the current will be flowing Ig. So what I can write, volt V potential will be equals to Ig whole into the resistance of galvanometer plus the shunt. Okay, so now let's see the question here. What it is given, we will have the potential difference of 10 volt. 10 volt it will be equals to the current that is 1 milliampere, that is 1 into 10 to the power minus 3, and what is the resistance of galvanometer, that is 100 plus the value of shunt. Okay, so this will be upon 1000, that is 1000 into 10, that is 10,000. 10,000 is equals to 100 plus S, which will be the S value will be 9900 ohm. So it will be equals to 9.9 kilo ohm. So what will be our answer? Option C is our correct answer. Here in this question it is given that the deflection in a moving coil galvanometer is reduced to half. Okay, when it is shunted with a 40 ohm coil. Okay, the resistance of galvanometer is. So what the question is asking, when we are shunting our resistance with the galvanometer, the deflection changes to half. Okay, deflection through the moving coil galvanometer changes to half. So what I will do here, the key concept, let's see it. Okay, so what in this question what we are doing, we are changing the galvanometer to ammeter. Okay, as the deflection it is given, deflection matlab kya hota hai, change in the current, value of the current. Okay, so I have here galvanometer, and with the parallel to the galvanometer I am fixing a shunt here. Okay, so this is the shunt, and when I is coming here and it is given that the deflection reduced to half, it means it is I by 2, and this will be also I by 2. Okay. So what I can write, let's say we will take a normal case. Okay, so this will be equals to, let's say this is I1 and this is I minus of I1. Okay, so what I can write, in the potential we know that in the parallel potential is equal, so we can write that is I1 into S is equals to I minus of I1 into RG. Rg is the resistance of galvanometer. So let's apply this concept. It is given that the deflection is changing to half. It means the current is changing to half. It means half of the current is flowing through the galvanometer and half will be flowing through the shunt. Okay, so by my applying my basic thing, I can directly tell you that the resistance of the galvanometer will be 40 ohm. Okay, by directly I will say why, because the current is dividing half, so half of the current will go to the shunt or galvanometer and half of the current will go to the other one. It means both have the same same resistance. That's why the potential drop will be same for both the cases. Okay, so let's find it out. Okay, so what we will write, the half of the current, it means I upon 2 into the shunt is 40 ohm is equals to I minus of I upon 2 whole into the resistance of galvanometer. So it is I by 2 into 40 equals to I by 2 into Rg. Okay, I by 2 cancel. So the resistance of galvanometer comes to be 40 ohm. Okay, so that's one I want to tell you that I can say it directly. I will not solve the question. Okay, this type of thing you should analyze and you should do also in the exam also. This will save a lot of time without calculation. How can you predict that? How can you just see the question and answer those one? Okay, these things you need to develop, because you are giving test for 180 question and 200 question. You have 200 question and you will have to attempt 180 questions, and it's not just a little cup of tea. Okay, so this require also a lot of practice and having the concept knowledge, clearance, everything required, speed, accuracy, everything required. For the Neet point of view, if you have some speed and your consistency is good and also you are doing accurately, then you are more than enough. You are the one who can compete in the Neet also. Okay, so if you don't have that type of speed, so do regularly 30 to 40 questions from physics point of view, I can tell, and from the chemistry also do 30 questions, from bio 60 questions every day you need to do that. I was doing in my preparation days. What I will do after the completion of the classes, I regularly read these topics also, and after that in the time of when I'm going to sleep or something, at the last period of time of the day, I'm talking about that. So I require I just do or solve some questions from the topic that I have learned at that day. Okay, and I will figure it out some 20 to 40 questions from the Neet, or 30 to 40 questions from the Neet, from those chapters, and from the chemistry also, from the biology also. And that I think biology I have done 60 questions every day, and that will help you out in a much bigger way, because you have that confidence in yourself that you can attend daily questions, daily you are achieving that, and daily you are attending those questions, and you are achieving the speed also, your accuracy also. On the first day I have done some more mistakes, and after that day, when I will try to solve more and more questions, this will reduce my my faultiness or my wrong attempted questions, or I have unattempted. That will reduce after day when I will solve these type of questions every day. Okay, मैं हर दिन करता था. हर दिन अगर करोगे ना, धीरे धीरे पहले दिन तो नहीं होगा, पहले दिन हो सकता है आप 50% स्कोर करो, but after those after some day you can be able to go beyond the 90%. Yes, I have done sometimes I have done almost correct. मतलब कभी मैं पूरा का पूरा ठीक ही किया हूँ, और कभी ऐसा भी हुआ है 60-70% भी आ गया हूँ, जो मेरा वीक टॉपिक होता है. तो वहां से आपको पता चल जाएगा आपका वीक टॉपिक भी कौन सा है, what you have not learned or understood. From that you can analyze also. Okay. So मैं जो बेसिकली मैं फील किया हूँ मेरे प्रिपरेशन डे में, मैं आपको शेयर करते रहूँगा. आप कुछ टॉपिक तो बताते नहीं हो, तो मैं इतना रिक्वेस्ट भी किया था, आई हैव रिक्वेस्टेड यू फॉर क्वाइट लॉन्ग that please tell me the topic so that I can come up for you and I can tell what you want. I will have some discussion, but no one is responding. Why? I will take care of you. Okay, that's nice enough. Let's see another question here. The 10% of the main current through to send 10% of main current through a moving coil galvanometer of resistance 99 ohm. The shunt required is okay. Like the same one I have told you. If I will tell the key concept here, we are changing galvanometer to ammeter. So what we will do? We will attach the shunt that will be parallel to the galvanometer. So in this question it is given that the 10% of main current is passing through the galvanometer. It means Ig it is I upon 10. Okay, if the current is flowing I here. So what will be the current flowing through the shunt? It is 9I upon 10. Okay. So what I will write, 9I upon 10 into the resistance of shunt, that is S, will be equals to I upon 10 into the resistance of galvanometer Rg, that is given as 99 ohm. Okay. So here 10 to 10 cancelled. It is cancelled. It is 11. So the I to I cancelled also. The value of shunt is 11 ohm. So simple questions. That is option 2 is our correct answer. It can do in a fraction of second. Okay, you can do nearly 20 question and you can proceed to next question also. Okay, this type of question also will be asked in the recent years. I think so. Maybe in the next year. So you should have to practice. You should have to have that speed of doing, have that speed of reading the questions, have that analyzing mind. How can you do it? You have to see ample of questions. Okay, practice ample of questions. Do PYQs. PYQ अगर करोगे ना, PYQ में बहुत सारे हो जाए. मतलब आप 70% you can score 70 to 80% from only PYQs. Only PYQ, direct to direct question will become. But just by changing some formulas or just changing from numericals also. Okay, बस न्यूमेरिकल को ही चेंज कर लेते हैं और कुछ नहीं होता है. बस थ्योरी आपका सेम ही रहेगा, मतलब कंसेप्ट आपका सेम ही रहेगा. सो डू PYQs, do questions. I am inspiring you. Yes, do that. If you will do, then you can score good maths and physics, and you can it will be easier to achieve your target, achieve your goal, that is becoming a doctor. You medicos are okay. You just aim to become a doctor. So no need to go beyond the level what physics. Yes, हम physics में पूरा PhD कर लेंगे, ऐसा नहीं. Okay, don't go beyond that. What Neet is trying to ask, just analyze the pattern and solve some questions related to that only. Okay. Here in this question, it is given that if reading of ammeter A1 in the figure, that is it is 2.4 ampere, what will be the ammeters A2 and A3 read? Neglect the resistance of ammeter. So in this question we know that these two are in parallel condition. Okay, you can clearly see these two are in parallel condition. It means the voltage drop between these two resistance will be same. मतलब ये अगर potential A है, ये अगर potential B है, so potential drop will be some VAB, and it will be for 20 ohm resistor and also for the 30 ohm resistor. दोनों के लिए same रहेगा. So what I can write, potential drop through the 20 ohm resistor, that is equals to I into R. Okay, so this will be equals to the current. It is given that the A1 is reading 2.4 ampere into the resistance, that is 20 ohm. Okay, so this will be equals to 48 volt. Okay, so this is 48 volt. It means along the 30 ohm resistor, this will be also 48 volt of potential drop will occur. So 48 volt is equals to I, it means ampere A2, sorry, it is the ammeter A2. What will be the current here? That is IA2 into 30. Okay, if I will solve this out, this comes to be IA2 value will be equals to it is 1.6 ampere. Okay, So this will be 1.6 ampere reading. Okay, 1.6 ampere. Okay, and this is 2.4 ampere it is reading. So what it will be when the current is passing here and here it is coming and it will divide like this. Okay, it is IA1 and it is IA2. Okay, so the main current will be I will be equals to IA1 plus IA2, that is equals to it is what 2.4 ampere plus 1.6 ampere, which will be equals to 4 ampere of current. So option B is our correct answer. Here another question, that is 5 identical lamps, each of resistance 1100 ohm are connected to 220 volt as shown in the figure. The reading of ideal ammeter. So let's have some more way of learning this question. Okay, more way of attempting this question. I know that these 5 resistors are in parallel. Okay, and what I need to find, I need to find the reading of the ammeter at this position. So what I will do, if I will fix the battery in this position, is it going to be affected? It is not going to be affected, I think so, because देखो अगर मैं इसको बैटरी इधर प्लेस कर दूं तब भी पैरेलल रहा ना. Okay, so the current, the potential drop across these all the resistors will be same. Okay, so I need to find out the current at this position. So let's ignore these 2 resistors. What I will do, I just want to find the equivalent resistance of these 3 resistors. If I will find the equivalent resistance, what will be my circuit now? Okay, I am ignoring these 2. Okay, so what will be my circuit? This is one resistor which will be the value R equivalent, and here an ammeter is there, and here it is the battery. Okay, which is 220 volt. So I can find the resistance, find the value of current, and I can answer the question. Okay, no need of these 2 resistors. Okay, so what I will do, the R equivalent for these 3 resistors is 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So R1, R2, R3 are all are same. It means 1 upon R plus 1 upon R plus 1 upon R. So it is equals to 3 upon R. R equivalent is equals to R upon 3. Okay, so R equivalent is equals to R upon 3. So I need to find out the value of current. I is equals to 220 V upon R. It means 220 upon R upon 3. Okay, so the value of R here it is given 1100 ohm. So 220 into 3 upon 1100. So if I will divide it by 11, so it is 100 and it is 20. So this will be 20 and this 5, 3 upon 5. Okay, what is the value of current? That is 3 upon 5. What will be our answer? That is option C. 3 upon 5 ampere is our correct answer. Okay, this type of question can be asked also. So you need to apply your basic knowledge. What you can do, what I have learned from the chapter, just apply the basic knowledge and do the questions, and try to do in a more easier way. Okay, in the figure, the difference of potential between point 2 and 4. Here point 2 is B. Okay, so it is B and D. Okay, B and D. So what I will do, let's see this. This 2 and 4 are in series. This 6 and 6 are in series. Is it a Wheaton bridge? Let's find it out. 2 upon 4, the ratio is 1 upon 2. Here it is 6 upon 6, the ratio is 1. No, it's not in the Wheaton bridge. Okay, this resistance, this setup is not in Wheaton bridge. So I can do what, this is these 2 are in series and these 2 are in series, and they are in parallel with each other. So let's take, and we know that in the parallel the potential drop is same. So let's take one setup here. Okay, divide the setup. We have here one resistor, okay, here one resistor. Okay, so this is R equivalent for this one, and this will be R equivalent for this one. Okay. So R equivalent कितना हो गया? 2 plus 4 6 ohm and this is 6 plus 6 12 ohm. Okay. So our current is I is equals to R equivalent is equals to R1 into R2 upon R1 plus R2. Okay. This is equals to 6 into 12, that is 72, upon 6 plus 12, that is 18. It is 4. Okay. 4 ohm is the R equivalent. So the value of current is 4 upon 4. It is 1 ampere. So from this 1 ampere is flowing and it will come here and divide into I1 and this is I2. And we know that potential drop between the this setup, it means across the 6 ohm and 12 ohm will be equal. So how I can write I1 plus I2, I know that it is equals to 1 ampere. And what another equation I can write, that is I1 into 6 ohm, I1 into 6 will be equals to I2 into 12. Okay. How I am writing? Because potential drop is same. Let's say this is V1 and this is V2. Okay. So for V1 I will write I1 into 6 and V2 I will write I2 into 12, which will be equal. So what I can write here, I1 is equals to 2I2. So from here I can analyze I1 plus putting this equation in the first equation. Okay. So in place of I2 I can write I1 upon 2 will be equals to 1 ampere. Okay. So this is equals to 3 I1 upon 2 is equals to 1 ampere. So I1 is equals to 2 by 3. If I1 is equals to 2 by 3, what will be the I2? I2 is equals to 1 upon 3. Okay. So we have to find out the potential difference at B and D. Okay. So what will be the drop along the 2 ohm resistor? So it is I1 into 2. It is 2 upon 3 into 2. It is equals to 4 by 3. 4 by 3 का ड्रॉप हुआ है, उसका मतलब पॉइंट बी में, इस पॉइंट में कितना पोटेंशियल होगा? मतलब 4 माइनस ऑफ 4 by 3. ओके. इतना ड्रॉप हो गया ना, 2 ohm में इतना ड्रॉप हो गया, तो कितना बचा? तो 4 माइनस ऑफ 4 by 3. इट मीन्स 12 माइनस 4, it is 8 upon 3. 8 upon 3 volt will be the potential at point B. So at point D, what will be the potential? कितना ड्रॉप हुआ है 6 ohm में, 6 ohm रेजिस्टर में? I2 into 6. Okay, this will be equals to I2 is 1 upon 3 into 6, that is equals to 2 volt का ड्रॉप हुआ है. If 2 volt का ड्रॉप हुआ है, उसका मतलब यहाँ पे कितना होगा? 4 minus 2, it is equals to 2 ohm, 2 volt remaining. So 2 volt will be at point B, D, and at point B it is 8 upon 3. So what will be our difference? 8 upon 3 minus 2, that is equals to 8 minus 6, that is 2 upon 3. Okay, 2 upon 3 will be our potential difference. That is, if I will tell 2 upon 3, that is plus of 0.67, which will be answer 1 will be our correct answer. Okay, I think you may get this, how I am solving the questions, how fast I am trying to do, how easier I am trying to do. So practice this type of questions and do well in exam also. Okay, this type of question often comes in the exam, so you can practice this type of questions from the Allied plan. If you have not any book, go for the Allied plan of the MemoNeet. There you will have the conceptual based questions and also the direct applied questions, some direct formula based questions. Okay, every type of question you will get, and you can see that this type of question I am having some concept also. Okay, इतना मतलब आसान से नहीं कर दोगे, आपको एनालाइज करना पड़ेगा, क्या करना पड़ेगा, क्या नहीं करना पड़ेगा. Okay, so let's see another question. So let's see this question. In the following circuit diagram, the value of resistance X for the potential difference between the points B and D is 0 is equals to. Okay, so what it is given, the potential difference between point B and D is 0. If the potential difference between the point B and D is 0, so which type of setup is this? This is type of Wheatstone bridge. Okay, because at that case we can write, that is, if these have the resistance P and this is Q, this is R, this is S, I can write P upon Q will be equals to R upon S. Okay, so this will be our key concept for this question. So let's find out the net resistance. I think you can't, it is not visible clearly. I will draw it for you. Okay. This is 15, this is 6, okay, this is 8 ohm and this is 3 ohm. Okay. This is 15 ohm, this is 6 ohm, this is X, this is 8 ohm, this is 3 ohm. Okay, find the equivalent resistance for this. Okay, for this this one and this one. Till that I will draw the next diagram. Okay, we'll have here 15 ohm and it is 6 ohm, this is also 6 ohm, 6 ohm, 6 ohm. Okay, this is 4 ohm, 4 ohm, and here another resistance is there. Sorry, another resistance is there, here another resistance. It is 4 ohm and this is also 4 ohm. Okay, it is attached to this. So what we have here, 15 and 6 ohm. So 15 plus 6, the equivalent resistance is 21. Okay, so this will be this upon Q. Q is the equivalent resistance for, what is the equivalent resistance for Q here? It is these two are in parallel. Okay, let's find out the have this equivalent resistance. I will not solve directly. Okay, I will take this as R. Okay, equivalent resistance, let's say it is Req. Okay, Req which will be equals to this one. If I will solve the equivalent resistance for this one, okay, 6 plus 6 and 6 are in parallel, then what I can write for these two, for these two, the equivalent comes to be 3. 3 plus 15, that is 18. Okay, 18 upon this one. Okay, I have 4 and 4 having in this parallel. So what I can write for these two having the equivalent resistance, that is as 4 by 2, that is 2. So 2 plus 4, 6. Okay, so if I will cut this will be 3. Okay, so Req comes to be 21 upon 3, that is equals to 7. Okay, the R equivalent, this one will have the 7 ohm. So we have here, if I will draw here, we have here X, here it is 8, here it is 3. Okay, this is 3 ohm, this is 8 ohm, and this is X. So what I can write, X 1 upon X, sorry, it is having two resistance. Now I can write directly also, 8 into X upon 8 plus X plus 3 will be the value of R equivalent. Okay, so R equivalent is I find it out, it is 7. So this is equals to 7. Okay, so 7 minus 3 is 4. So 8x upon 8 plus x will be equals to 4. Okay, so if I will take this 8 plus x to the RHS side, we have 32 plus 4x is equals to 8x. So 4x is equals to 32. So x is equals to 8. Okay, so our option C will be our correct answer. The galvanometer of resistance is it is 25 ohm and gives a full scale deflection for current of 10 milliampere. It is to be changed into the voltmeter of range 100 volt connected in series. So the resistance value R is, okay. So resistance of the galvanometer is R and we have to find out the value of R. Okay. So here we have the same thing, that is we are changing the galvanometer to voltmeter. So what I can write, V is equals to Ig whole into R plus S Rg. It means resistance of galvanometer. Galvanometer resistance कितना दिया गया है 25 ohm. So the volt I need to change, that is of 100 volt. 100 volt is equals to Ig. What is I here? 10 milliampere. It is 10 into 10 to the power minus 3 whole into Rg, that is 25 plus S. Okay. So I need to find out the value of S. S means here it is R as it is given in the question. So I will take it as R. Okay. So here the value of R will be equals to 100. 10 to the power 3 will be in that side. It means 100 into 1000 upon, if I will take 10 to this side, this will come to the denominator. This much minus of 25. Okay. Solving is your part. What I am not doing, I am just telling you how to solve quickly. Okay. So this will be equals to 10,000 minus of 25, it is 9975. So option 4 is our correct answer. Let's see this question. In a meter bridge, the null point is obtained at the middle point of the wire. If one gap of the resistance is 10 ohm, the value of resistance of the other gap. Nothing in this question. देखो, first we will try to find the key concept. Okay, key concept. अगर हम देखते हैं तो मीटर ब्रिज कैसे होता है. This one is one resistor R1, this is R2, and it is connected to a 100 centimeter length wire. Okay, and here will be your null point. Okay, something here will be your null point. Okay, what I can write, if this is L1, this is 100 minus, let's say this is L, so this is 100 minus L. Okay, so what I can write, resistance is directly proportional to length. So it, as the length will change, the resistance will change. Okay, so I can write by applying the Wheatstone bridge, R1 upon R2 will be equals to L upon 100 minus of L. Okay, so like that, like this, what I will do, that is the one of the resistance, it is given that 10 ohm, and we have to find out the other one, R2 is equals to, it is at the null point is at the middle point. It means 50 centimeter upon 100 minus 50, it is 50 centimeter. So this will be equals to 1. So the value of R2 is same, that is equals to 10 ohm. I can directly tell that because as it is achieved in the middle, it means both the resistance should be same. Because if this will have at the middle, okay, then equal resistance will be there for the Wheatstone bridge. As we will do L upon L1 upon L2, it is equals to 1. It means the resistance will also have the ratio 1. For that, they should have the same resistance. So how much will be answer? Option A is our correct. Let's see this question. In the circuit shown below, the reading of the voltmeter and ammeter will be. Okay. So here, before I will go to the question, I just want to tell you the key concept. In the ammeter, what we need? The resistance of ammeter should be, what? Lower. Okay, lower. Why? We need that maximum to maximum current will pass through the ammeter so that we can easily detect how much current it is passing. If ammeter will have some resistance, then the potential drop will occur. Then maximum, then we can't get the maximum current as we required. So resistance of the ammeter should be lower or 0. Okay, for the ideal ammeter we are taking the resistance 0. And if I will talk about the resistance of voltmeter, okay, what do you want? The resistance of voltmeter to be infinite or greater. Okay, why? We need the current will pass through the circuit and through the load or the resistance, for which we are trying to find out the potential drop across the resistor. If I will have some resistance which will be of lower value, and we can calculate that. So the current will pass through the voltmeter it will not pass through the that much of current will not pass through the resistor. For that we'll get the incorrect reading for the voltage drop. Okay, as we'll have, let's say we'll have a resistor here, and here it is a voltmeter. Okay, if voltmeter is something 5 ohm, okay, and this resistor is 10 ohm, okay, some current will pass through this. So some current will pass through the voltmeter and some current pass through the 10 ohm resistor. So we will not get the actual value of actual drop of in between the 10 ohm resistor. For that we take the voltmeter, the resistance of voltmeter to be infinite. Okay, so let's now see this condition. Okay, let's now see this one. Okay. Okay, so we have here two circuits. For the circuit 1, I will say the current will be IA1 will be equals to 10 upon R. Here the voltage resistance is infinite, so no current will pass through it. So all the current will pass through this 10 ohm resistor. So 10 upon 10, it is 1 ampere. Okay, so V1 will be, V1 is equals to I into R1, that is I is 1 into 10, that is equals to 10. For the second circuit, here when I will have the current here, okay, current will pass here and here, and when the current will pass through the voltmeter, this voltmeter is of infinite resistance, so the current will not pass through this. इन्फानाइट रेजिस्टेंस के लिए कितना करंट पास करेगा, 0.0000, वैसे इन्फानाइटली स्मॉल ही पास करेगा ना, उतना करंट स्मॉल पास करेगा, तो हम नहीं लेंगे उसको, तो हम हमारा पूरा का पूरा करंट किस में पास कर जाएगा, 10 ओम रेजिस्टर में. ओके, सो वी विल हैव हियर द IA2 as equals to V upon R, that is 10 upon 10, which will be equals to 1 ampere, and V2, okay, V2 will be, what is V2 here, V2 हमारा कितना हो जाएगा, कितना ड्रॉप होगा, how much there will be drop in between this 10 ohm resistor. In this 10 ohm resistor, how much potential will be drop? So current will be 1 into 10, that is equals to 10 volt. Okay, so I have here V1 is equal to V2 and I1 is equals to I2. So which will be our answer? Option C is our correct answer. Let's see this question here. We have B1, B2, B3 are three identical bulbs connected as shown in the figure. When all the three bulbs glow, the current is 3 ampere recorded by the ammeter. Okay, what happens to the reading of ammeter A1, A2, A3 and A when the bulb B2 gets fused? Okay, so let's ignore the value of current. I will tell what will happen to the current, okay, to the reading of the ammeter. So let's have the current here I. Okay, I is equals to V upon R equivalent. Okay, here R equivalent, let's say this is R, this is R, and this is also R. Three bulbs having the equal resistance. So at initial condition, the R equivalent will be R upon 3. Okay, at when the bulb B gets fused, the R equivalent is equals to R by 2. So this is increasing. Okay, the R equivalent, when one bulbs get fused, then the R equivalent is increasing. So what I can comment about the value of current V upon R equivalent, here R equivalent is increasing, it means current will decrease as current is inversely proportional to R equivalent. Okay, so current will decrease. Okay, so the reading of A will decrease. What I can comment about the A1, A2, A3. In A1, in A2, it means bulb 2 is getting fused. It means there will be no current passing through this. And we know that if I am taking here this voltage V, this is also V, this is also V, this is also V, because there is no resistor so that it can drop the voltage. If I am taking this as zero potential, it is 0, and this is also 0, the same reason. Okay, all the bulbs are having the same potential difference. So the current whether we are ignoring this one, when the bulb B2 is fused, it will not affect to the bulb B1. Why? Because the voltage drop is equal in both the cases. Okay, so the I A1 or the reading of A1 and A3 will not change, and but for the A2 the current will become 0. Why? Because there is no resistance to drop the voltage. So the current becomes 0 for the A2. A1 and A3 will the reading will not change, and for the main current, that is A, for the reading of A, the value will decrease. Okay, I think you understood this this question. If you have not understood, please watch it again. Still doubt, then you can ask me. 3 light bulbs 60 watt 120 volt are connected across the 120 volt power source. If resistance of each bulb does not change with the current, then find out the total power power delivered to these 3 bulbs. Okay, so for the total power I need the resistance here. So let's find out the resistance. Okay, resistance will have, I have, that is R is equals to V square upon P. So V square is equals to 120 into 120 upon the power, that is 60. So this will be 2 into 120, it is 240 ohm. Okay, so for the resistance, for one resistance it is 240. So I have like this type of setup, okay, where these two are in parallel. So these two are in parallel and having the equal resistance. So what will be the net equivalent resistance of these two? Okay, these two, what will have the net equivalent resistance? Okay, I will now have like this type of this is R by 2 and this is R. Okay, so so we will have the equivalent resistance across the battery, R plus of R by 2, it is equals to 3R by 2. So where the value of resistance is 240, so 3 into 240 by 2, it is 123 into 120, it is 360 ohm. Okay, so the R equivalent comes to be 360. So what it is given? Power delivered I can write P is equals to V square upon R. So it is 120 into 120 upon 360. Okay, so 120 360 cancel 3 and 3 to 120 cancelled, it is 40. So what will be our power? 40 watt. Okay, so our correct answer is option C. This is one type of question which I have not covered in the lecture. The color code for of a resistance is given and we have to find out the value of resistance. Okay, so before that I just want to tell you on a simple trick, that is B.B. Roy of Great Britain had a very good wife. Okay, so let's find it out, the what it stands for. B is for black. First B black, then brown. Okay, let's simplify it. Okay, it is of Great Britain had a very good wife. Okay, so this is for B is stands for black and it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so this is brown, this is red, this is orange, this is yellow, then green, then blue, then sorry, it should be up to 9, not 10. Okay, this is not 7. Okay, sorry, this one is 7, 8, 9. Okay, 7, 8, 9. Okay. So this is violet, then gray, okay, then white. Okay, so this is the color code, and for that code we have assigned some number. So black for 0, brown for 1, then red for 2, and orange for 3, then violet for 4, green for 5, blue for 6, violet for 7, grey for 8, and white for 9. Okay. So here it is given that yellow, violet, brown, gold. Okay. It means for the yellow we can write 4, and for violet we can write violet 7. Okay, 47. And first two quantities is for the number, and then we are trying to what we want to tell, we are trying to have the number set up like something x into 10 to the power something. Okay, so x will be in 2-digit number. Okay, so like this, so 47 into 10 to the power, let's say it is y. Okay, 10 to the power brown is for 1 10 to the power 1. And for gold for the gold, if I am taking gold, I have the percentage, that is plus minus of 5%. And if I am taking for gold here, and if I am taking for silver, it is plus minus 20%. Okay, so it is given as gold. So what will be our answer? That is plus minus of 5%. So it is 470 plus minus of 5%. So option C is our correct answer. Like this type of question you have to practice more. Just apply the concept, just apply my trick, and you can able to solve any other question which will be asked to you. Okay, this question also comes in the NEET exam. I think this one also has come in the NEET exam. This question is an NTA PYQ, I think so. Okay, so you can refer. This is our last question from current electricity. Let's do that, and let's see this question. After that I will discuss. As the temperature increases, the electrical resistance will be. Okay, so we know that R is equals to R naught whole into 1 plus alpha del T. Okay, alpha is the coefficient of temperature for different material, and we know that for the conductors alpha is positive, insulators and semiconductors alpha is negative. Okay, so as the temperature is increasing, the resistance will increase for the conductor, and this will decrease for the insulator and semiconductors. As we can write, you can see here, resistance is directly proportional to the alpha. Okay, that is coefficient of temperature. So it will increase for conductor and decrease for semiconductor. Increase for conductor but decrease for semiconductor. Option 2 will be our correct answer. Okay, with this I finish my part, that is for the current electricity. I have done over 100 of questions from current electricity. You can see from any other section, that is from the lectures, from our quizzes, from this revision video. Okay, now your part comes. You have to solve the question and ask me the doubt. Okay, you can refer. What you will do, you at first complete NCERT. From the NCERT also direct question comes. Complete the theory part of NCERT and also the examples, and also those exercise question, and with the NCERT exemplar. These two you have to complete. Then go for any book you are having, problem solving book, you can do that. If you are not having, you can go for the Elite plan from the MemoNeet. You will have ample of questions there. Okay, solve those. NTA PYQs is must. You have to solve for the 5 years at least. Solve for the 5 years, and with that watch those lectures, and it will more than enough for you. Okay, I think don't think beyond that any other question will come. Okay, So with this we have done the revision video for the current electricity. In the next lecture I will be taking kinematics. I think so I will be coming up with kinematics. Till that, stay tuned. Bye bye.